Hi, in this video we are going to talk about string data structure. The good thing about string data structure is it has characters which have limited values. All these values in a string are ranged from 0 to 255. They have only 256 possible values. So there is something called ASCII value. Every character has an ASCII value. That's how characters are stored. Small a, for example, has ASCII value 97. B has 98. All these values are contiguous, right? So C has 99, then D has 90, then D has 100, then E has 101. Similarly, capital A has value 65. Then capital B has 66, capital C has 67, capital D has 68. So that's how these values are. So with this limited character size, there become many interesting interview questions on a string. For example, if you want to sort a string, how will you sort a string? If you use a normal sorting algorithm, you will take big O of n log n time. But since the character size is limited, you can sort a string in big O of n time. You can use counting sort and sort this because the values are from 0 to 255, and you can sort this string in big O of n time. So here are some common functions on string data structure in C++ and in Java. In C++ we create a string this way, and there is a function called find which tells you whether a substring or a character is present in the given string or not. So if the given string is present at multiple locations, then it returns you the first occurrence index. So this geeks is present 2 times. This is present here and present here. But it returns you the index of first occurrence, which is 0. So the output for this part is 0. So now you can guess the output for this. For this output would be 0, 1, 2, 3, 4, 5. This occurs at index 5. Other function in C++ is substr. So this first parameter of substr is begin index. The second parameter is length. It tells you the substring beginning from a given index, end of given length. So we have the begin index as 1. So it gives you the substring EEE. So the output for this would be EE. The output for 4 was 5. So the output for this program is 0, 5, EE. Similar functions are there in Java. So this is not a complete set of functions. I've just written some most popular functions in data structure. There are many more functions present in C++ library. So similar functions I've written in Java. Index of works same as find function in C++. It tells you the index of first occurrence. For example, geeks is present at 0 index. Right? For is present at index 5. Substring function in Java is different from C++ function, although it also returns the substring. It tells you the substring beginning with this index, same as C++ here, but this second parameter here is not length. This is end index, and this is exclusive of the substring. So if I'm passing the end index as 3, it tells me the substring beginning from 1 and ending with 2. 3 is not included. So I get the output here, EE. I get the output for this as 5, output for this as 0. Let us now talk about the first question on string data structure. So the first question is, given 2 strings, we need to find if they are anagram of each other or not. 2 strings are called anagram if they have same set of characters and every character has same frequency in both the strings. Basically, we need to check if 2 strings are permutations of each other or not. So if you take a look at this example, E occurs 2 times here, it also occurs 2 times here. All the other characters, they occur 1 time here and 1 time here. So these 2 strings are anagram here. And if you look at this example, A appears 2 times here, but B appears 2 times here, and B appears once here. So these are not anagram of each other. So please pause this video and try to write down a solution yourself. You need to come up with a solution which is big O of n time, where n is the length of the strings. So a naive solution is to traverse through every character of the first string, count how many times it appears in the first string, then count how many times it appears in the second string. And if these 2 counts are different, then return false, otherwise move to the next character. Overall time complexity of this solution is big O of n square. Say n is the length of both the strings and both the strings are of same length. then this solution is going to take big O of n square time. So the idea of big O of n solution is, we traverse through the first string, we count frequency of every character. How do we count frequencies? We know that all the characters are in range from 0 to 255. We can use character values as integers. They are automatically treated as integers in both C++ and Java. And we can use these integer values as an index in a count array. So we initialize this count array as 0, 0, 0, and this array is of size 256. We traverse through the first string, increment the count of every character. So this way, this count array has the count of every character in the first string. Now, we traverse through the second string and we decrement this count for every character. So at the end, as you might have guessed, all the values in this count array must be 0 if these two strings are permutations of each other. If any of these values is not 0, then we say they are not permutation. One thing we can do is, before we do anything about the count array, we can check the lengths first. If the lengths are not same, then we immediately return false, because two strings of unequal lengths cannot be anagram. So we first check the lengths. We make a count array with all the values 0. So in C++, I need to initialize this way. In Java, values are by default 0, so I don't have to write this thing. Then I traverse through the string first. In Java, I don't need to write these brackets. I increment the count of every character in first string. Then I traverse through the other string and decrement the count of every character. At the end, I check if any value in the count array is non-zero. If that happens, I immediately return false. And I come here when all the values are 0, so I return true. So what is the time complexity of the previous solution? As we mentioned, it is actually big O of n. We are traversing through the string 1, then we are again traversing through string 2, and they are of same length, then say n, that's going to be big O of n. And then we traverse through an array of size 256, which is a constant work. But if you want to be more precise about the time complexity, you can write this way: big O of n plus alpha bit size. This alpha bit size actually indicates that 256 traversal loop, which is a constant. So if you write big O of n, that also sounds okay. But if you want to emphasize on this thing, that this also runs a loop equal to alpha bit size, then you can mention that value. And auxiliary space required by the previous program can be written as big O of alpha bit size. And we can also write it as big O of 1, because alpha bit size is constant. If we consider this as a constant value, 256 value. Let us now talk about the second question. In this question, we are given a string and we need to find the index of the character that repeats and whose first appearance is the leftmost. So there are many repeating characters here. And which one is the repeating and has first index as leftmost? G. Because its leftmost index is 0. If we take a look at this example, A does not repeat, B repeats, and index of leftmost occurrence is 1, so we get the output as 1. In this example, no character is repeating. So if no character is repeating, our output will be -1. A naive solution to solve this problem is to traverse through the string for every character, check whether it is repeating on this right side or not. So you run a loop for I equals to 0 to n-1, then you run a loop for j equals to I plus 1 to n-1, then you check if strj is equal to stri. If you find such a character, you return I, right? And at the end, when you come out of both the loops, then you return -1, then nothing was repeating. But the time complexity of this solution is big O of n square. First of all, try to come up with a solution which is big O of n. Then try to come up with a solution which does only one traversal of the input string. We are not allowed to traverse the string more than once. A simple big O of n solution is traverse the string once, count frequency of every character, right? Then traverse the string again, and then for every character, check if its frequency is more than 1, then print it, then return the index of this character, right? And if you don't return anything in this loop, then at the end you return -1. This solution is big O of n, but requires 2 traversals of the input string. Can you do it with 1 traversal? So the idea of 1 traversal solution is, we store the leftmost index of every character. We traverse through the string, for every character, if it is appearing first time, then we mark its first index in an array, right? And if it is repeating, then we check whether its first index is smaller than the current result. So we initialize a result as infinite, right? Then we initialize the first index array as -1, -1, -1. So here I've initialized this way. This is not a valid syntax in C++ and Java. Just to save space on whiteboard, I've just written the array, initialize the array this way. You can use a loop or you can use built-in functions. Once I've initialized the first index as -1 for every character, now I traverse through all the characters. And here I check if it is appearing first time or not. How do I check? If its first index is -1, that means this character has not appeared before. So I store its first index in this fi array. This fi stands for first index. And if this is not -1, then this means this character has appeared before. So if a character is repeating, then I check whether its first index is smaller than result or not. If it is smaller than current result, then I update the result. At the end, I check if result is infinite. That means, I did not find any repeating character, so I return -1. Otherwise, I return result. So let's do a quick run of this. For this string, initially I have an array of size 256. So first index of every character is -1. I traverse through this. I update its first index here as I, which is 0. I come to E. Right? I update its first index as 1. I come to E again. So this time I go to else part. And what do I do is, I update the result as 1. Because result was initially plus infinite. Right? When I come to K, I update its first index as 3. Then I come to S, update its first index, come to F, come to O, come to R, and for every character, I update their first indexes. When I come to G, I see that it is also repeating. I go in the else part, I compare the result, and I find the first index as 0. So I update the result as 0. So after processing G, result remains 0, and at the end, I return 0. So the idea is, initialize first indexes as some invalid values, because -1 cannot be an index. Traverse through the character, and since you find an invalid value, that is how you figure out, okay, this is the first occurrence. So you store the first index. And if you see that character is repeating, then you compare the result, and then you see if this first index is smaller than the current result or not. There is even a better solution. This solution also traverses the input string exactly once and does less number of comparisons. The idea is to traverse from the right. So when you traverse from the right side, I begin the loop from str.length -1. I don't have to do that comparison. If the current value is smaller than the result, then only update the result. Because when you go to the left, you will have the leftmost repeating character, the character whose first appearance is the leftmost. So I avoid that min comparison here. I've rewritten that part. Earlier there was a min here, and this loop was from 0 to str.length -1. So I've started from the rightmost character, and here I'm saving one comparison. This solution does one traversal and is even faster than the previous solution. Let us now talk about question number 3. In this question, we are given a string. We need to find the leftmost character that does not repeat. So let's take a look at this example. We have G repeating, we have E repeating, we have K repeating, we have S repeating. F is the leftmost character that does not repeat, right? So there are more characters, but F is the leftmost. In this example, all the characters are repeating, so our output is -1. This is trickier than the previous question. If I ask you to solve this problem, to do only one traversal and get me the first non-repeating character, then it becomes really trickier. And that is why this has been asked in almost every company. This is like one of the most popular interview questions on string data structure. A naive solution to solve this problem is you traverse through every character. For every character, you check whether it is repeating or not repeating. If once you find a character that does not repeat, you return index of it. And if you did not find a character that was not repeating, you return -1. So a big O of n solution better than big O of n square, you traverse the string 2 times. First time you traverse through the string, count in occurrences of every character, and then you traverse one more time, and you, for every character, you check if its count of occurrences is 1. Once you find such a character, you return its index. So this solution requires 2 traversals of the input string. Let us now talk about a 1 traversal solution. I will strongly recommend you guys to still pause the video and try this yourself. Try yourself doing once. You don't want to miss the fun of doing yourself. So the 1 traversal solution is works this way. We initialize again all first indexes as -1, but this is first non-repeating, not first repeating, right? So this one character which is not repeating might become repeating again. So what we do is, if we find -1, that means this character has its first appearance here, so I store its index. And if it is not -1, then I need to unset the value. But I can't unset it to -1, because if there are odd number of characters, for example, there are 3 G's. So first time I'll initialize it to first index of G. Next time, if I again make it -1, then the third character will again store the first index of it as a non-repeating character, although it's a repeating character. So what I do is, so I use another value, -2, to indicate that this character was repeated. So we do 1 traversal of the string. This is how we find the indexes of only non-repeating characters, because once they repeat, we set them to -2. Now we do 1 more traversal, but this time we are not traversing the string. We are running a loop that runs constant number of times. So this is not counted as string traversal. And in this traversal, I'll just consider all those first indexes whose values are greater than or equal to 0, because they are the valid indexes. They are the one who went in there but did not went in there, right? Did not go into this part. And I consider all those indexes and just find the minimum of those. And those are all indexes of non-repeating characters. So that's how I find the result. Here I can add again one more check. If result is int max, then return -1. Otherwise return result, because they might be all repeating characters. Let us now talk about the question number 4. We are given a string. We need to find lexicographic rank of it. What do we mean by lexicographic rank? If you sort the given string and write all the permutations in increasing order, then where does the input string come in? So you have BAC, you sorted all the characters, then you started writing them in increasing order. You basically wrote all the permutations in increasing order. And then you checked where BAC is coming. It's coming at number 3. So your output is going to be 3. CBA, you again sorted it, writed it in all increasing order. CBA comes at number 6. So your output is 6. For string, output is 598. So if you generate all the permutations of these characters, then increasing order, then you check where string is coming. You will find it comes at 598 position. How do you solve this problem? A naive solution to solve this problem is follow these steps, sort the input string, generate all permutations one by one. You need to write a function that generates next permutation. Fortunately, in C++, you have a function to do next underscore, to find the next permutation. The function is next underscore permutation. But this solution requires lots of time. You need to generate factorial n permutations in worst case. And to generate next permutation, you need some more time. Can you think of a solution which is big O of n time? Let us now talk about a big O of n solution. The idea of this solution is to count lexicographically smaller strings than the given string. How do I get this count? I use some mathematics here. The idea is I count all the strings which do not contain s as a first string. So how many characters I can put in place of s to get lexicographically smaller strings which do not have s as a first string. So I have 4 characters on right of s which are smaller than s. And whatever character I put here, I then have factorial 5 permutations for remaining positions. So count of strings which do not begin with S and are lexicographically smaller than this string are 4 into factorial 5. Now I fix S and I count strings which are lexicographically smaller and can contain S as a first character. I come to T and I count how many characters are smaller than T. There are 4 characters smaller than T, so I have 4 into factorial 4. Now I come to R and I see how many characters are smaller than this. There are 3 characters smaller than this, so I have 3 into factorial 3. When I come to I see that there is only 1 character which is lexicographically smaller than this. So I have 1 into factorial 2. When I come to N, I see that there is 1 character which is lexicographically smaller than this. So I have 1 into factorial 1. So this is the count of strings which are lexicographically smaller than this. I add these values and add 1 to it. And that's the lexicographic rank of the given string. So this value is 597. I add 1 to it and I get lexicographic rank as 598. Let's understand it better by using one more example. Let's say we have the input string as BAC. So we can see its lexicographic rank is 3. Let's see how do we get 3 using our approach. We count how many characters are smaller than B. So we have 1 character. And once you fix that smaller character here, you have factorial 2 permutations which are smaller than this string and do not contain B as a first character. Now I fix B, I go to the second character, then I see how many characters are smaller than A and are on right of A. So there are 0 characters, so I'll have 0 into factorial 1. So the count of strings which are smaller than this are 2 plus 0, and lexicographic rank of this string is plus 1, which is 3.